Today we're going to be talking about the energy density found in food, and specifically the energy density found in spaghetti. We've talked previously about specific heat, or heat capacity, but only in conceptual terms with energy. Just to refresh our memory, can someone tell me what specific heat specifically means? Yes, it has something to do with heat energy. And yes, it has to do something with changes in temperature. Good. So then here is a summary of what we've talked about. So specific heat, or heat capacity, relates the amount of heat required to change the temperature of a substance. So for example, if we're talking about heating or cooling steel metal or liquid water, it's the amount of heat required to change that temperature of that substance. And here's the formula we've used previously. Q equals Cp m delta T, where Q is heat energy in joules, C is the specific heat or the heat capacity of that substance, m is mass, and delta T is the change in temperature. And as the change in specific states, that is the final state and the initial state of that substance. And this idea can also be applied to the food we eat. So that's right. So even though we've calculated specific heat in terms of heating up metal or water, the energy that powers your body is the same energy that can heat a glass of water, for example. It is just in a different form of energy. So for food, I like spaghetti. What sort of food do you like to eat? So write down some things you like to eat. So what are some foods that you like to eat? Pizza, that's one thing. Ice cream, good. Meatloaf, alright. Banana split, that's a good one. Strawberries and cream, very good, okay. Great, so first we'll talk about spaghetti, since I like spaghetti. But keep in mind what you like to eat, because later you'll be able to figure out the energy that you can in that kind of food. So even though we've talked about different forms of energy, heat, sound, chemical, light, there's no distinction within these types. Remember, the unit for the SI unit for energy is joules, so we can still measure all these different forms of energy in joules. But then when we eat something, we usually measure that energy in calories, and that is just a holdover from a previous time. But whether from food or from a battery, heat energy behaves the same way. But we can't eat batteries, but instead we eat food. So when you're hungry, is a signal from your body to eat, because eating food provides not only nutrients but also energy for your body. And what is the kind of energy that food provides? So we've talked about chemical, heat, sound, light. There's nuclear. What kind of energy does this food provide? Right, so in some ways, food provides heat energy. If the food is hot, like let's say we're eating Salisbury steak that's just been made, but most of the energy that our body gets comes from chemical energy. So we eat food for the chemical energy. So unlike sound, light, energy, and even heat for the most part, we eat food that contains chemical energy. And your body converts this chemical energy not only into other forms of chemical energy, but also heat. So you get heat from food. And you can feel the heat generate from your body. For example, go ahead and feel your neck right now. So the neck is an exposed area that gives off a lot of heat. So that's why, for one reason, we wear scarves when it's cold, so that we can insulate the neck, so we can preserve the heat that is escaping from our body. So eating replenishes the body's source of fuel, and different things we eat can provide different amounts of energy. And just because you eat something doesn't your body has to convert in order to be used, and that process is digestion. So digestion processes food energy into usable forms. And the heat generated from your body is not just a wasted byproduct of digestion. It's part of homeostasis. And we've talked previously about homeostasis, but can someone remind us again what homeostasis is? Right, so then homeo is the prefix for still, for consistency, good, and then stasis, the condition, right. So then homeostasis is the stable, constant conditions your body maintains to stay alive. So what are some things that your body does to stay alive? Well, breathing, right. We breathe on a normal basis in order to provide our bodies with oxygen, good. So that is a form of homeostasis, constant breathing. But then what about in terms of heat? All right, well then let me ask you in this way. So instead of heat, let's think about temperature. Is there a temperature that your body maintains that is primarily stable or constant? Do we change temperatures throughout the day? Well, no. The typical temperature for your body is about 98.6. And, this is roughly plus or minus 1 degree Fahrenheit. And, we say this is typical. Your body isn't always at 98.6 at different times of the day. Like at night, for example, your body temperature might decrease. And then, this is not when you're exercising, let's say, when your body temperature might be higher. But so 98.6 is the optimal temperature for your body. So then, how is it that your body uses this heat? Good, so your body protects, the heat protects your body from your environment. So if you're cold, you shiver. Okay, and then good, you adapt to different ambient temperatures. So even though you're inside a room and it might feel very pleasant, and you step outside and it's very hot, your body roughly keeps that same temperature. Good, and then also, if your body gets too hot, then you'll start to sweat. Good. So then, food is our way. Eating food is our way of the body maintaining homeostasis in terms of temperature. And so then, not all foods are the same, right? So some food have more energy than others, and so we will say that kind of food is more energy dense than others. So, for example, this chicken leg on the left has 208 calories per 100 grams. And then a strawberry, for example, strawberries, for 100 grams of strawberries, only 32 calories. And so here's an interesting fact. 1 kilogram of coal, so 2.2 pounds of coal, has less energy than roughly 2.2 pounds or 1 kilogram of pure fat. So then, the lesson is, if you eat too many energy-dense foods like fast food or junk food, your body will store the excess energy from these foods as fat. So it's a good idea to eat healthy and balanced meals. And one way to figure this out is the energy density of a food. So here, we mentioned spaghetti at the very beginning. And so we'll use this as an example of how energy dense it is. So I found this recipe for Dad's spaghetti on allrecipes.com, and it lists the ingredients: spaghetti, ground beef, onion, tomato paste, tomato soup, and water. And from this, I used another site, self.com, to calculate how much energy I can get from cooking this recipe, Dad's spaghetti. So here in the nutrition facts, Dad's spaghetti, the whole serving size is a little over a pound, 2.8 kilograms, and that is about 3,000 calories. And so, to get an idea of just how much energy 3,000 calories is, let's answer this question. How much water at room temperature can be boiled from the energy derived from Dad's spaghetti? So what formula could we use to figure this out? That's right, the formula for specific heat. So Q equals Cp m delta T. So then the heat that we get from Dad's spaghetti is 3,071 calories. And then the substance that we're using to heat up is water. So that has a specific heat of 1 joule per gram per degree Celsius. And then we're boiling it from room temperature. The boiling point for water is 100 degrees Celsius, and then room temperature is about 25 degrees Celsius. And then the answer, or the question is, how much water can we get from that? So then here, we'll calculate just that amount. So then, Q equals Cp m delta T. And then we'll have to do a little converting, right? What is, because we'll be dealing with SI units, and calorie, is that an SI unit? No, it's a US customary unit. Good. So then 1 calorie with a big C. Does anyone remember the conversion to that? To an SI unit. So it will be something in joules, in kilojoules, for a big C calorie. Good. So it is 4.184 kilojoules per 1 calorie. Okay, so we're saying that the heat derived from Dad's spaghetti is 3,071 big calories. And so we have Cp also, that is the specific heat for water. And we said that it is 1 joule per gram per degree Celsius. And then the change in temperature is the final temperature minus the initial temperature. So we're saying that it's 100 degrees Celsius minus 25 degrees Celsius. That's room temperature. So we have all the variables and what we're looking for. M, the mass of water that can be boiled from room temperature. Okay, so then let's isolate M. So if I divide on both sides, Cp and delta T, I get M on one side. So that would be Q divided by Cp delta T. And then now we can just plug in the numbers. So we have 3,071 calories. But what, is there something that we forgot to do? That's right, we need to convert calories to joules. So remember the conversion here. 1 calorie is 4.184 kilojoules. So then we can convert right here, 4.184 kilojoules divided by the specific heat, so that's 1 joule per gram per degree Celsius, and then the change in temperature, so that is 75 degrees Celsius. And then you'll notice that here is kilojoules versus joules. So what we can do is change this to just joules. So instead of 4.184, we'll just say it is 4,184 joules. And that is per calorie. So then calories cancel, so we're in unit of joules now. Joules cancels out with joules. Degrees Celsius cancels out with degrees Celsius. The only unit left is grams, and grams will go on top because any fraction divided by another fraction in the denominator will have grams on top. And so we're looking for the mass, and we have the unit gram, so we have done the calculation correct. So then what is the answer that we get? We get 171.976 grams of water. So then that is also roughly 171.976 milliliters of water. And this is a little less than 1 cup of water. So and remember, we used about 2.8 kilograms of spaghetti. Spaghetti to heat up, to boil a small fraction of water. So then another consequence of this is to say that water has a very high specific heat. It takes a lot of energy to change the temperature of water. Okay, good. So now we've talked about the energy density of water, the energy density of spaghetti, specifically dad's spaghetti. So remember the favorite foods that you listed earlier? I remember someone saying meatloaf or pizza. So now I'd like you to do your own energy analysis. So you can find a recipe at allrecipes.com. I'd like you to find a recipe with at least 4 ingredients. So with our recipe, we had a little bit more than 4 ingredients. Remember, onions, spaghetti, beef, tomato, water. And then I'd like you to use figure out its nutritional content on self.com. And then you can calculate how much water can be heated up, kind of like what we did here. How much water can be heated up from the total amount of food for that recipe.